Hi, everybody. Welcome back. Today, we'll be starting Chapter 2, Intro to Python for Machine Learning. The concepts you'll learn here will equip you with the tools in Python to perform and execute the machine learning algorithms that we will learn in the following chapters. Let's get started. Today's video format is going to be a little bit different. We'll be doing a live coding session. Let's get right into it. So please open to Google Colab. Just search that in your browser. Once you get to Google Colab, open a new notebook. Press the new notebook button and you should be in the right place. We're going to talk about how to use Google Colab because that is the online IDE that we'll be using throughout this course. So here I am in my Google Colab notebook, and I have a little cartoon for you here. And it says, before you can do the really cool ML stuff, could you clean this data really quick? So a lot of times in machine learning, we're going to be given this data. And beginners are compelled to just get right into it and use some algorithm, apply it to the data, and say, hey, I got 98% accuracy. Am I done? No. You have to clean the data first. You have to understand the interactions between the different columns, correlations, and make sure that your data isn't corrupt. And this is super important because when your data is corrupt, your algorithm could be one of the best architectures, one of the best algorithms out there. But if it's operating on corrupt data, your results don't mean anything. Okay. So first, we'll talk about Numpy arrays. Why do we use Numpy arrays as opposed to regular lists? Well, Numpy arrays are memory efficient and fast, and they also have special attributes that allow us to understand what's inside of them, their shape, and we'll get all into that in just a moment. So, how do we import our Numpy library? Go to the cell that's open in your Google Colab notebook and type import Numpy as NP. What does this mean? Import Numpy as NP means we're importing the Numpy library and we're calling the Numpy library NP for short. Really simple, and you're going to see this with other libraries like Pandas, Seaborn, Matplotlib. Okay, now that we've imported our library, let's make our first Numpy array. To make a Numpy array, all you have to do is create a variable a, and then type np.array in parentheses. Now, in the parentheses, you need a set of objects, values, floats, whatever it might be, in square brackets. So we'll start off simple and put a few integers into our array. Say 0, 1, 2, 3, 4, 5. So we have 6 numbers in our array. Now let's print out our array and see what it looks like. Press print A and run the cell. We get our array 0, 1, 2, 3, 4, 5, as you see at the bottom here. Okay, now you might ask, how do we access individual elements within a Numpy array? Well, it's pretty simple. It's just like a list. So we'll use a for loop structure to access the individual elements of our Numpy array. We'll say for element in a print element. Now we have the individual elements of the array printed out. Okay, but that's pretty simple. Could we do other stuff? You remember a few minutes ago, I talked about how Numpy arrays have really special attributes? What if you were given an array of values of sleep hours, and you were trying to calculate the average amount of sleep a student gets at ASU? Well, what you could do is compute the arithmetic mean by hand. But who wants to do that? We have computers. So Numpy has a really special function called .mean. Given a set of values in our Numpy array, we can easily compute the mean. So let's show that. We'll comment this out and comment our print array out, let's compute the mean of our array. All we have to do is the name of the array dot mean. Once we print that out, we get our mean, 2.5. Now, you can validate this by adding up all of the individual elements and making sure that this is right. 5 plus 4 is 9, plus 3 is 12, plus 2 is 14, plus 1 is 15, plus 0 is 15, divided by 6. Yeah, that's 2.5. Okay, now what if we wanted to know what is the data type of the elements in our array? This is very important when we're looking at a data frame which is composed of NumPy arrays, and we want to understand what is the data type of the data that we're looking at. We'll deal with many data types in this course: strings, integers, floats. We'll cover it all. But now let's see how we can get the data type of our NumPy array. Simply a.dtype. Now, what's special about NumPy arrays is that we can actually get the data type and we can change the data type. So first, let's get the data type of our array. So we compute the mean and we get dtype equals int64 right here. Okay. Now, what if we wanted to change the data type of our NumPy array? Let's say I wanted to change the individual elements to strings. How would we go about that? Well, NumPy is powerful, and we can use a method called asType. Let's see how that works. So if we wanted to change the data type of our NumPy array to strings, what we would have to do is say a.asType. And then in the asType, we're changing the NumPy array to a string type, str. Now what we'll do is we will print a.dtype as we did previously. Let's see what we get. Still int64. Now, why is this? It's because we haven't declared a to the new array with string types. Whenever you change a NumPy array, it's crucial that you redeclare it to the original variable name. Let's do that. So we declare a equal to a.asType string, and you'll see now that the data type is a string. To double check this, what we can do is iterate through the individual elements and check the type of the elements. So we'll say for element in A, print the type of element. As you can see, the type of the individual elements are NumPy strings. Great job. You just converted NumPy arrays from integers to strings. What else can we do with NumPy arrays? Well, we can also have two-dimensional arrays. How would we go about that? So to instantiate a two-dimensional array, let's create some space here. A little bit more space. To instantiate a 2D array, let's create a variable as we did before, b, and set it to np.array, parentheses, and square brackets. It's the same procedure. But now we want it to be two-dimensional, so we need an extra set of square brackets. So we have this extra set of square brackets. What do? Well, like we did with the one-dimensional array, we just enter an element, 0, 1, 2, 3, 4, 5. Okay, but now what? This is not two-dimensional. It's just a NumPy array with an extra set of square brackets. So you need to add another set of values. So delimited by a comma, you enter in another set of values, 6, 7, 8, 9, 10, 11. This is a two-dimensional array. Now it's important to understand the structure of the array, so I'll make it easier by pressing enter here so you guys can see kind of what this looks like. 0 and 6 correspond, 1 and 7 correspond, 2 and 8 correspond, 3 and 9, 4 and 10, 5 and 11. Now, here we see quite clearly 2 rows and 1, 2, 3, 4, 5, 6 columns. This is kind of like what the structure of our data is going to look like. We'll have entries under individual columns that might look like this. The only difference between this and an actual data set is the data set will probably be labeled, and the type of the values might not be an integer, it might be a string or a float. So now what? How do we access elements within a 2D array? Great question. Well, what we can do is, let's try to access 0, this number right here. So let's comment this out so this doesn't print out. Let's try to access the individual element 0. Remember how before we just used the for loop, like for element in A, and just printed out the element? Let's try the same thing. For element in B, print element. Should work, right? Okay. What is this? This is not what I wanted. I wanted the 0 value. Why is that the case? Because when you're trying to access individual elements in a 2D array, you have to specify the row and the column. B in square brackets 0 specifies row 1, and B in square brackets 1 specifies row 2. If we wanted to access the element 0, we would have to go to row 0 and then column 0 to access that value. So if we wanted to see every value in the first row, we would say for element in B0. Print that out, and then we would get every element. Nice. Okay, let's move on. Sometimes in our projects, we might need arrays of certain values. Like we might need an array of all zeros or all ones. How might we create an array of all zeros or ones? Well, there's 2 ways to do it. You create an array and add values of 0 until you feel like you have enough zeros, or add values of 1 until you have enough ones. Or you could use NumPy's nifty np.zeros and np.ones. Let's see how we might go about that. So this is how np.zeros works. So we'll create an array. We'll call it C, and we'll say np.zeros. Now, there's a few arguments. There's the shape and the data type. We'll define the data type to be a float. Now, let's print out C and see what we have. What just happened? We specified the shape as 0, so nothing printed out, which means that the shape defines how many elements there are in our zeros NumPy array. So let's change this to 5. Let's see what happens. Okay, now we have 1, 2, 3, 4, 5 zeros. Makes sense, right? Now, what if we wanted a 2-dimensional array of zeros? How might we go about that? Well, 2 rows, 5 entries. Oh, there we go. We have a 2-dimensional array of zeros. Makes sense, right? We just entered in a new shape. It's a tuple with entries 2 and 5, 2 denoting the amount of rows, and 5 denoting the amount of columns. Pretty simple, right? Okay, we can do the same thing with ones. Ones works the same exact way. np.ones. You can enter in some shape. We'll say some crazy shape like 60 and 1. We want to get 60 rows of 1 zeros. This is going to be a little wacky to print. And we'll specify the data type to be an int. Let's see what this prints out. Oh my God, 61s, look at that. All in a NumPy array, individual entries. So now you've just about learned everything you need to know about NumPy arrays and NumPy functions for this course. In the next video, we'll be talking about importing data with pandas. I'll see you there.